In the Unit 4, Section 4 lab, we're going to explore the concept of limiting reactants by creating chalk from two components, calcium chloride and sodium carbonate. We're going to mix these together into some distilled water, create our chalk, and try to predict which reactant will be limiting and which reactant will be in excess. Without further ado, let's get into it. Before we start talking about our procedure, let's take a look at our two chemicals. Our first chemical, calcium chloride, is relatively benign. It's not very harmful, but it can dry out your skin, and more importantly, it can be harmful if it gets in your eyes. Really, the only protection here where you have to really worry about is our safety goggles. If any gets on your skin, wash it off, and if any gets on your clothes, just brush it off. Our second chemical, sodium carbonate, is even less harmful. We obviously don't want to ingest it. We don't want to get it in our eyes, but as long as we're wearing our safety goggles and using it appropriately, we'll be okay. Again, wash your hands if you get it on your hands, and brush it off your clothes if it gets on your clothes. Now, the first thing we need to do in lab is to weigh our filter paper. At the very end of our lab, our product, our chalk, is going to be stuck to this filter paper. So we'll need to subtract the weight of the filter paper out after the lab is over. First things first, I'm going to write my name on this so that when my sample is complete, I'll be able to figure out which sample is mine. So now that I have my name on it, I'll put it on the scale, and this is the weight I will record. My filter paper is 0.37 grams. Make sure to record this weight exactly as it is on the scale before you do anything else. The next thing we'll need to do is weigh out our samples. I'm going to start with sodium carbonate. That's my Na2CO3. What I'll do is I'll place a clean, dry beaker on the scale, and I'll press 0. So now whatever I put in this beaker is just sodium carbonate, Na2CO3. This is arguably the more important of our two sample weights. We want to weigh as close to 1 gram as possible, so 1.00 grams. So for my Na2CO3, I'm going to weigh out as close to 1 gram as possible. And this is true for every group. Every group will weigh out as close to 1 gram as possible. Now you can see this isn't a lot of sample, but it's not a small amount either. So be careful, tap kind of your wrist or your hand as you get close to 1 gram, and we are good. Oh, I went a little bit over. That's okay. Plus or minus 0.01 or 0.02, that's okay. If possible, try to get 1.00 grams on the dot. Now we want to record this weight for our Na2CO3. For our second sample, calcium chloride, we'll do the same thing. We'll place a new beaker on the scale and press 0. And now we need to weigh our calcium chloride, our CaCl2. For this sample, you will have a certain amount for your group that you want to target, and that will be different for groups across the class. The idea is different groups will have different results, but will create a class set of data at the end. For my sample, I'm going to weigh out 0.50 grams. Your group's amount might be different. So I'll scoop some of my calcium chloride into my beaker. Calcium chloride is the sample that looks like little granules. I'll scoop it out. I'll get as close to 0.5 as possible, 0.50. If this result is a little bit off of your mark, that's okay. We want to be close, but we don't have to be quite as careful. Now, I went a little bit too far over. I'd prefer to get a little bit closer to 0.50 if that was my target, but this honestly doesn't mess up my final results. Make sure to record this amount for your CaCl2, your calcium chloride. Now for the next part of lab, we're going to be dissolving our two samples, our calcium chloride and our sodium carbonate, in distilled water. Make sure for this lab you are only using distilled water in the bottle. If you use tap water, your results will be off. So first, I'll squirt some distilled water in my calcium chloride. This should dissolve pretty easily. You probably don't need a lot of water. I might have used more than I needed to. And then simply swirl your sample until it dissolves. Should take no more than 30 seconds or so. Your sodium carbonate is a little more difficult to dissolve. You may need to use a little bit of water, but I'll squirt some in the start. And again, gently swirl this. You might notice this is not necessarily going to dissolve after 30 seconds. You may have to keep swirling. I'll also have some hot plates out. If it's really having trouble dissolving, you could put in a little more water. You don't have to put in too much. Or you might put it on the hot plate to help this dissolve. But again, swirl for 30 seconds, a minute, maybe give it some heat on a hot plate until this fully dissolves. Now the next part of the lab is very simple. With my two samples dissolved, we're going to mix them together. I'm going to mix the calcium chloride into the sodium carbonate, but really it doesn't matter which you mix into which. I'll pour it in. And now we want to make sure we get all of the calcium chloride in this beaker. What I'll do is I'll hold this beaker over my other, and I'll squirt the sides with some fresh distilled water to rinse out any reactant that is not reacted. Now that this is rinsed and I have all the calcium chloride out, I will stir my mixture with a glass stir rod to make sure the reaction is complete. And that really is the reaction of chalk. We actually have some chalk suspended in this water. Now let's filter it out. Now that we have our chalk suspended in water, our goal is to filter out the water so we can measure exactly how much chalk we made. The way we're going to do this is we'll take a device called a Buchner funnel. You can see it has these holes here in the bottom, and we will pour our chalk into this funnel with our filter inside and catch the chalk on our filter. I recommend putting your filter name side down in the funnel and then actually putting that funnel in one of these vacuum flasks. This will catch the water as we separate the water from our chalk. I also recommend taking a little bit of distilled water and wetting the filter so that it sticks well to the filter, to the funnel that is, before we start actually filtering out our sample. What you can do is take your vacuum flask and attach it to the house vacuum line with one of these rubber tubes. We'll attach the vacuum line, or the rubber hose to our vacuum line and to our vacuum flask, and now we are ready to filter. When you turn on the vacuum, you'll see your filter kind of get pulled into the funnel. Now, before I start actually filtering out the water from my sample, I want to make sure I catch all of the chalk. So we can see this glass stir rod has a little bit of chalk on it. I'm going to wash that chalk onto my filter using my distilled water. We want to make sure we capture all of our product. Now that my glass stir rod is cleaned of that chalk and we've caught it on our filter, I will filter out my sample. The name of the game here is to go slowly. If we were to pour all the water in at once, the water would actually sneak past the filter and the chalk would end up in our vacuum flask. We wouldn't be able to measure it. So make sure to pour slowly in the center of your filter. I'll pour my sample slowly, and the vacuum will pull air and your sample onto the filter, and the water will go into my vacuum flask while the chalk will get left behind on the filter. Pouring slowly, I'm letting the vacuum pull the sample onto the filter. Now, once you've poured out your sample, you'll notice there is still chalk left in your beaker. Go ahead and rinse this with distilled water to make sure we get all of our chalk. You may need to repeat this step 1 or 2 times because there may still be chalk left after your first rinse. I can see on my beaker there is still some chalk. I should do this again, but for the purposes of this video, I'm going to move on. Now that our chalk is caught on our filter, we actually have to wash it once or twice with distilled water because there can be some salts still in our chalk that we don't want to weigh. I'll take my distilled water and I'll rinse once. I'll let the vacuum pull the sample onto the filter and pull the water through. I'll wash my sample again, just with a little bit of distilled water. And once it looks dry, I'll rinse my sample one more time. So that's 3 times total. I'm now going to let the vacuum pull the air across my sample for around 20 or 30 seconds to give a preliminary dry. And then after that 20-30 seconds is over, I'll turn off my vacuum and I will break the vacuum line by pulling up on my rubber stopper. You can hear the air kind of get pulled into the vacuum flask. Now the last step is to fully dry our sample. There's still some water caught in it. To do that, we'll get a watch glass and we will place our sample onto that watch glass using a pair of tweezers. I recommend putting the chalk side up, so your name side down, so the chalk doesn't get on the watch glass. Now we can dry this in the oven. And now that I have a dry sample the next day after lab, I'm going to take my filter paper with my chalk on it. I'll zero this scale so that it reads 0, and I'll place my sample on the scale. Now remember, this weight includes the weight of the filter paper. So subtract out that 0.37 you got at the start, or whatever your filter paper weighed, to get just the weight of your chalk. And check to see, does your final weight of chalk match what your stoichiometry predicted? And make sure to consider limiting reactants when making this determination. We'll come back together, assemble all of our class data, and see if limiting reactants has an effect on the amount of product created.